brief introduction. I'm Andrew on GitHub and tbass on Twitter. For those of you who are wondering, does my laser work? Yeah. This is my rabbit, Bertie. He's Bertrand Rabbit on Twitter, and Mr. April 2014 in the Bath Cats and Dogs Home calendar. Slightly more famous than me. Some of you may know me from the London Node user group. I've been running that for about 2 years, and I recently just ran my own conference, the Great British Node Conference. So I know the kind of crazy stuff that's going through Remy's head right now. It's not easy. So any talk about JavaScript where you're talking about something experimental, you have to talk about Atwood's law. I think it's pretty much a rule. Any application that can be written in JavaScript will eventually be written in JavaScript. And we've seen this. This was said, I think, in 2007 by Jeff Atwood. We've seen this over and over again. That's really dark, but we've got Quake running in the browser. All cross-compiled into JavaScript. So there's no external dependencies there whatsoever. We've got libraries that can detect nudity running in purely JavaScript that you can run in the browser. We've even gone so far that someone has compiled the Linux kernel as JavaScript that runs in your browser, and you can compile JavaScript inside of JavaScript. And there's even a subreddit of all of the crazy things that you would never expect JavaScript to be able to do, and yet people keep doing that. And what I've seen in the past 6 months to a year is that people are starting to take Atwood's law outside of the browser, outside of Node, into the real world, and they're actually making really crazy things with JavaScript. A great example is BuildCat. This is a build monitor for your CI systems, built by Alex Potsides. Flashing means it's checking. If the build breaks, then the cat is not happy. And then he's going to go and check to see if the build is OK again. And it's good. Yeah, we're happy again. So this is what he looks like under the covers. It's a fluffy toy cat with a Meccano frame and an Arduino. And all of the software is written in JavaScript. He's open source. His brains are up on GitHub. And you can check him out. And this is basically what I'm going to be talking about today, this kind of the ability to take control of the physical world using JavaScript as your programming language. Hardware hacking with JavaScript. So why would you want to do this with JavaScript? There's already pre-existing languages and frameworks for doing this in C and assembly, and people have been making embedded devices that they've been selling for many years. Like, why do we need to reinvent the wheel and do this all again in JavaScript? And I think there's a few compelling arguments as to why you should do this. For one thing, we're at a higher level than most existing technologies. JavaScript removes that need to worry about pointers and memory allocation. And with hardware today, as we're mobile phones especially driving the kind of the rate of technological change with CPUs and chips, that we don't need to worry so much about saving every individual byte of RAM in a microprocessor. We can be a little bit more lax, which means we can not have to worry about the details and go a little bit higher. And that means we can think at a higher level as well, have better abstractions, and be able to get more done more quickly. Another really nice feature of JavaScript is that it's asynchronous, which, when you're working with hardware, which blocks and delays and has errors and potentially sits there doing nothing for a while, you really don't want to be waiting for your hardware to come back and actually just blocking the rest of your code. JavaScript is a perfect fit for that. As we've seen with Node on the server side talking to I/O, it really makes sense to use something like that. It also lowers the barrier to entry. Rather than having to understand C and assembly, you can already use the language that you probably already know. And And it turns out JavaScript is kind of popular. So I did the search on GitHub archive.org yesterday, which is an archive in Google's big data query website. There's close to 1 million open source JavaScript repos on GitHub at the moment. So there's quite a bit of pre-existing code that we could potentially make use of whilst building and hacking on hardware things as well. And then the really interesting thing is this amazing buzzword, the Internet of Things. No one really knows exactly what the Internet of Things is. I personally think it's things that are on the internet and connected. It's a little bit simpler. And no one's trying to own things being connected to the internet, whereas companies are saying, oh yes, we are the Internet of Things. Like, no, the internet is the Internet of Things. But JavaScript is the language of the internet. So it would make sense that we can write our internet-connected code in JavaScript and the code for our hardware in JavaScript. We'd be able to share JSON between the two devices really nicely. We'd be able to even share modules potentially in the same way that people can write modules for Node that can run in the browser. We could potentially have things that run on a microprocessor that can also run inside of Node and the browser. That kind of saves you doing re-implementing all that stuff all over again. So let's look at some different bits of hardware that you can use to actually get started on this and have a play around. So first up is the Arduino. This is like probably the most well-known hacker's bit of hardware. It's super accessible, super easy to use. There's loads of ecosystem and add-ons and community and documentation around the Arduino. And what we're going to do is control the Arduino using JavaScript. But we're not going to put JavaScript on the Arduino because it doesn't have anywhere near enough resources, disk space, CPU. It couldn't run a proper JavaScript emulator. Instead, we're going to use a library called Johnny-Five, which runs in Node. And it talks to the Arduino over a protocol called Fermata. It's basically what we're going to compile onto our Arduino. It's written in C, which is what the Arduino compiler handles. And that then connects to your laptop using over a serial port, so USB, Bluetooth, and provides a protocol for talking to the Arduino in any language. There's lots of libraries in Ruby and Python, but we're going to use Node because we like JavaScript. And we're able to set and read the data for all of the pins on the device just using regular JavaScript. So here's like the hello world of Arduino code in JavaScript. We're basically going to make an LED flash. That's like, hello, I can make hardware. So we're requiring the Johnny-Five module, which is available on NPM. And then we basically create a new board. I can't see where my laser is. There it is. And because hardware is not necessarily instantaneous, we have to wait for it to connect. We get a callback. And then we create a new LED object. And Johnny-Five kind of takes an approach of, it likes to be kind of like jQuery for hardware in that it abstracts a lot of the implementation away. So we don't have to worry about how we're going to talk to this LED, what kind of, is it a digital or analog pin, things like that. We're just going to say, our LED, as you can see in the little fritzing diagram, is plugged into pin 9 on our Arduino and ground. And then we inject it into a REPL, which is very much like in your developer console or your JavaScript console. You can actually interact with this LED object and change it as the program is running. And then we're going to say, pulse this LED for, turn it on and off every 500 milliseconds. And then after 10 seconds, just turn it off and stop because we don't want to go on forever. So that's really quite simple. You can easily run that today, and kind of that's the first thing to do if you're going to get into hacking with JavaScript. But that's not very inspiring, being able to flash an LED. So let's have a look at some of the things that people have done that are a little bit more interesting. So this is Rick Waldron, the creator of Johnny-Five, has hooked up a Kinect, which also has a Node module. It turns out pretty much every bit of hardware that you can plug into a USB has a module on NPM nowadays. And he's mapping the joins of his shoulder and his elbow to move servos. So he has a robot arm doing exactly what his arm does. We have a little walking robot. This is basically just 4 servos. If you can imagine, all it's doing is for a set of particular positions to move the servos in. Doing those all at a given time means that you can walk a little robot along. And this is all written in JavaScript. You can see the Arduino is hanging on a little stand at the back there, so it's tethered at the moment. And what we're going to do next is I've actually brought along an Arduino. I have it down here. And I thought we could build, Remy said, can you do something practical? People that can, like, not demoware. So like, well, lots of people have cats. Let's make a laser cat toy. But I don't have a cat. I'm highly allergic to cats. So we're going to make a rabbit laser toy instead. So here's the circuit diagram. We've got 2 servos, and servos, these are standard like servos that you get in a remote control car. We've got power, a ground, and a signal, and we've plugged the signal wires into pin 10 and 9, and then our laser, which for all intents and purposes is the same as an LED, is plugged into pin 8. And then all we're going to do here is, again, connect to Johnny-Five and create a new servo object for each servo and an LED, and then turn our laser on. And then every 400 milliseconds, we're going to randomly move both servos in any direction so that the laser will move around. So let's actually switch out of this and change back to mirroring, and we can actually run this. Ooh, wrong webcam. Hello. Is that going to work? Come on. Let's quick time. The demo gods are not kind. Wow, that is slow. This is probably something to do with my 1 GB Keynote file. Where have you gone, QuickTime? Oh man. I'll give you one more chance. How does this happen? Like, the hardware is all ready to go. I can make lasers shoot out of cats' eyes and things, but I can't show my webcam on my screen. No? Okay. Yeah, we can definitely do photo booth. He says. Ah! All right, let's imagine you can see down here, but we're going to run the code anyway. So I've got the same code here, bunny.js. I'm going to run it. And we have the laser down here. And you should be able to see if there's any cats in the audience, if they're going to be running around like crazy now. So I came with a backup. I should probably stop that, right? Nice. So I thought, let's try out on Bertie, let's see what he does. He's fluffy and cute and small. Turns out rabbits really don't care about lasers. Who knew? I think it's something to do with rabbits not being predatory animals. Like, grass doesn't usually dart around like a mouse. So he's just like, yeah, whatever, where's the food? Like, could not be less interested in my robot. Anyways, So Johnny-Five is up on GitHub. There's really good documentation and great examples for all different types of bits of hardware. If you're interested in this, I highly recommend looking into the Spark Fun Inventors Kit. You basically get a little bit of all kinds of different electronics that you can plug in with a breadboard and an Arduino, so it's all easy to kind of get started with. And this website here is an Arduino guide that's been rewritten to use with Node.js and Johnny-Five instead of the C++ examples. So next up is Lego. I absolutely love Lego. I just wish that I could control my Lego with JavaScript. So this is the Lego Mindstorms EV3 kit. It's a kind of a kids programming tool as well as a fun Lego kit. And it comes with some really interesting bits and pieces. So we've got some motors and some sensors and a remote control. But the brick in the middle actually is a Linux machine, similar to a Raspberry Pi. It has Bluetooth. You can plug in a Wi-Fi adapter, and you can then attach it to all of your Lego. And because it works with Bluetooth, you can actually talk to it over a serial port, similar to how Johnny-Five works. So I've made a rabbit feeding device. This is essentially a repurposed Lego tank with a hopper on the front that you can spin that motor and it will eject rabbit nuggets out of the thing in an attempt to get Bertie a little bit more interested in my robots. So I've split the code in half. Here's the first bit. This is really just setup. So we're requiring a node module which already existed on NPM for communicating with the Lego Mindstorm over Bluetooth. We're also controlling the robot using my Xbox controller. So I wrote a library called Xbox controller. It was an obvious name to choose, really, so that I can drive around the robot and try and kind of get Bertie to go where I want him by dropping crumbs of food. And then we connect to the robot on the serial port and set up some speeds. And then what we're basically doing here is whenever I move my Xbox controller stick, we get a callback that says, here is the X and Y position of the left stick, translating that into the movements of the tank tracks. And then if I press A, I will turn on the motor to eject food, and if I let go, then I'll stop the motor. And then we're setting all those on a speed object, which is emitted over the Bluetooth serial port connection every 100 milliseconds. You could do it faster than that, but then you get a little bit of a lag, so that I found is the sweet spot over Bluetooth. So let's have a demo of that. I don't... Oh, hello. Photo booth. How do I change my... Where's my map? Oh, who knows? So anyway, we don't need to worry about this because I have the Lego all ready to go. Oh, hello. You can't see it right now. Wait for it. It's not the fastest thing in the world, but it is JavaScript-controlled Lego Mindstorm. And then we can... I don't have any rabbit food with me. Bertie had eaten it all by the time I finished. But as you can see, we can, using the Xbox controller, eject that, and then drive off. And I'm just logging out some values to see what I was doing there. But as soon as you think, like, I can actually drive my Lego around the room with my Xbox controller, the possibilities are endless. And ooh, I have to kill this. I've got too many node processors. Oh, should have upgraded. Kill-9, you're gone, node. Okay, so just in case that didn't work, turns out Bertie is a little bit more interested if the robot smells like food. But it is moving around, potentially a predator. So he's a little bit apprehensive, and he's not quite in the mood for eating. Like, I'm not sure if he couldn't see the food, or he's obviously interested in the robot. So he's following it around. He doesn't quite know what to do about it. I gave him a little bit more time, and eventually he accepted it as his new master. This is like rabbit-driven development. I love it. So this robot is also up on GitHub. There's not really much code to it, but if you do end up with a Lego Mindstorms kind of thing, you could potentially reuse this to create. You can even just, if you take the kits that you can build with the instructions that come in the box, you can use this to drive them around in a similar way. It comes with a ball gun to shoot balls, but I thought shooting rabbits is a little bit harsh, especially as he could probably destroy that easier than it could destroy him. There's also a really interesting library that I spotted a couple of days ago. I haven't had time to play with it yet. Really new, because the EV3 is only maybe a month old. There's no documentation for the serial port, so you can't find out how to talk to it very easily. What this guy's done is, instead of trying to work out, reverse engineer the serial port API, he has just gone, okay, screw it, we'll just install Node on the Linux that runs on the brick and run Node internally. I was like, what? Linux on my Lego? Blew my mind slightly. Still a little bit scared of like running kernel updates on my Lego. So for the moment, I'm happy to leave it like that. I could just have that GIF going all day long. OK, so we've got Lego, we've got lasers. Let's go on to Nodecopter. Nodecopter is my obsession at the moment. It's basically programmable flying robots. I need to turn this one on. It's these are AR drones, which are just like big kids' toys, kind of rich kids' toys because they cost about £250 each. But we don't have to make any hardware modifications to them at all to be able to control them. And the nice thing is that they're absolutely full of sensors. Similar to the Lego, they run Linux on board. They've got a slightly faster CPU. And all of the other tech is very similar to like a flying Android phone almost. Which I think is partly why the cost has come down so much. And so with this much sensor data and a nice API, you're able to control them and do all kinds of crazy things. Again, there is a Node module. It's called AR Drone, and the code is up on GitHub. And this is all the JavaScript you need to make a robot take off, spin around, flip in the air, and land. And basically, Skynet is only one step away from that, really, isn't it? So I want to share a couple of projects that I've seen people do or I've worked on myself. QR coder takes a command that has been encoded into a QR code and shown to the camera of the drone, which then it will execute. This is probably the only valid use of a QR code I've ever seen. Then we have the drone controlled through the medium of interpretive dance. So we've taken a dance mat, which is very similar device to a PlayStation 3 controller. And then you're able to dance along and get the drone to dance with you. The Gangnam style was not part of the code base. And then if you jump on 2 commands at once, then you get some kind of extra special function. Didn't always work. As with most flying robots, you never really know what they're thinking. But you can get some quite cool dance moves going on. Yeah, I love it. Of course they crash. Of course they do. So I wanted to do a demo. This demo is a little bit experimental. Can I get the lights up?
Red slide on.
Oh yes, of course. Yes, the warning. So it is a flying robot. I am going to fly it around the room. It's got 4 large spinning blades on it. First thing is, don't stick your fingers in it. It likes fingers. Other than that, it should be fine. I'm only really going to fly up here. If Skynet happens, we've got bigger problems than one flying robot. So let's swap. We're already in the right frame of mind. So I'm using a project here called, hello. Let's just see if that, you know, I think my USB hub's turned itself off. Let's try this again. That's better. So I'm using a project called Ardunio WebFlight. What this does is it pumps the data from the AR drone back up into a web browser and then visualizes it. I don't know if we have much of a video connection here. It could be a Wi-Fi related thing. Let's give it one more try. Ah, I'm not even connected to the drone. So the drone shows up as a Wi-Fi hotspot, and I didn't turn it on beforehand because when I've done that before, some smart ass with the app on their phone has just taken it off whilst talking. And not that I don't trust everyone here, but it is a flying robot. Let's give this another try. What's that sound? Is that like... The robot's coming. The robots are coming. Let's give this one more go. Oh, I haven't got any... Do we take off? Yeah, we can take off. Just don't have any video feed. Again, the demo gods love me. It appears that we've got a little bit of Wi-Fi interference, which the video feed is always the first thing to go. But what you can see is... Am I even connected to the... I must be. We're not getting much data back from the drone. So I'm controlling this using the keyboard, which is the default function. There's the crowd. And what should usually happen is you would get the... this is a horizon line running across the middle of the screen. And that would tilt as the drone moved around, very similar to as if it was a like a heads-up display in a helicopter. So let's land that. And let's just make a... So potentially the video stream can be a bit funny. It's pumping H.264 frames up over a WebSocket into a canvas element, which is 3D accelerated using WebGL. So it's got all of the different buzzwords kind of rolled up into one project. And the nice thing about this is it's made up of lots of different plugins. So we've currently got the H.264 video stream, but what we really want is the troll face plugin. And we're going to disable these two because they require that one. Yeah, let's give that, there we go. That looks better. Aha, and we have video feed, awesome. So, the theory is, if the drone is now, before the video comes up to the browser, is being pumped through OpenCV and it's looking for people's faces. I'm also using the HTML5 game API, gamepad API, I can control it using the Xbox controller. Or keyboard. So what we're going to try and do, he says, that's incredibly slow. Okay, we're not going to use the Xbox controller right now. The hardware is with me. Ah, there we go. Okay. Is we're going to fly up to Jeremy. And we're just going to troll people. Copter, it's landed itself, okay. Ooh, can I switch my screens back? Yeah, there we go. Okay, so again, that project's up on GitHub. Really nicely, well built up Node project. Lots of nice little modules that build it up. So it's a really good canonical example of a well-built Nodecopter project. And when you have such a nice high-level API, I like to think of it as quadcopters as a service. You don't worry about the implementation or how the rotors are spinning or anything like that. You're actually just using it as if you're using any other kind of API. So then you can start mashing it up with other things. And we could actually mash it up with our cat laser and produce robot laser pong, where we have a game of Pong running in a browser, 2 Nodecopters, 1 for each paddle, and then it's quite hard to see on this screen. You should be able to see it soon. There is a red laser point moving around following the ball. This is all being streamed back from the web browser that's playing the game to a Node process, which is controlling this laser here and 2 drones simultaneously. Of course, trying to have a Nodecopter perform on stage is a guaranteed way to make it go crazy. But it's quite fun to be able to then start combining different services, different APIs all into the same project, because with everything being in JavaScript, it's really easy to just link the things together. You don't have to worry about translating or talking over different protocols. So let's just talk about JavaScript microcontrollers quickly. This is a topic that's appeared in the last couple months, led by Tessel, which is pretty interesting. They received about $200,000 in funding of their Kickstarter-like campaign fairly recently. And what this does is it doesn't run JavaScript on board. It actually compiles JavaScript into Lua and runs Lua inside of a C interpreter. The thing with this, though, is it's really quite expensive. The board itself is about $70, and you need to buy modules to plug into it. So they take a very beginner approach, like you're going to have to plug and play this kind of stuff. But it should be really easy to use. Should be available early next year, I believe. Around a similar time, a lesser-known project came out, also kickstarted and raised about 100 grand. Again, there's a lot of money being thrown at these chips, is the Arduino. And this takes a completely opposite approach, where it says, we're not going to try and wrap this up into nice, neat, expensive little modules, just solder stuff onto the board. This doesn't do any translation into Lua. It actually just takes the JavaScript code and runs it inside of a C program called tiny.js. So you don't have the full JavaScript, you have a subset of JavaScript. But it means with both of these things, you can unplug them from your cable once you've transferred the JavaScript onto the chip, and they can run completely autonomously. Alternatives right now, as you cannot get either of these until January, you could use a Raspberry Pi. So Raspberry Pi has a pinout. It has a fairly nice CPU in it. You can compile Node onto it. I wouldn't suggest compiling it yourself. It takes about 8 hours. Instead, just copy a cross-compiled one from somewhere else online. The only thing with the Raspberry Pi, its pinout, if you just use the raw board, have no protection. So you could potentially plug the wrong bit of electronics in and fry the whole thing. Another fairly new chip coming from the Arduino family is the Arduino Yun. This is an Arduino Uno with a separate Linux chip on board, which has Wi-Fi, Ethernet, and USB. Essentially, as if you took a Raspberry Pi, plugged an Arduino in over USB, and then ran the two like that. You can SSH into your Arduino, compile Node on there, or move a cross-compiled binary onto there, and then you've got the whole setup as if I had my laptop and my Arduino all in one single nice chip. Just to compare, looking at the different prices, not too much, but if you're going to be building a project that potentially needed multiple microcontrollers, the Arduino could be a really good way of making that a lot cheaper. a lot more affordable. If you're going to want anything with displays, the Raspberry Pi is definitely the best bet to go for because it has a HDMI output. But potentially you can run JavaScript on all of these different devices, which is pretty exciting. The future is moving really fast, and JavaScript is definitely a big part of the hardware hacking world in the future. So one last thing is all of this stuff has kind of happened around Node. Node has been broken out of the browser and then given access to all of the file system, all of the APIs in your computer. But what we're starting to see now is some of this development that's happened in Node is coming back into the browser. One big proponent of this, a big driver, is the Firefox OS and Firefox mobile phones. They've already got a number of APIs that actually let you talk directly to the hardware of the phone from JavaScript, from running in, usually in the apps. Often these APIs are protected, or you need to be a privileged app to be able to access them. And they've got a list of all of their APIs on Mozilla.org. But the ones that really interested me are things that are tagged as future. So that's UDP APIs. That means that you could talk to a Node Copter directly from a web page in Firefox OS. And if it's in Firefox OS, how long until it's in Firefox on the desktop? And you're able to then talk to a Node Copter from any machine that has Firefox on it, which is a heck of a lot of machines. NFC and Bluetooth mean communicating with devices that are nearby. You could essentially have responsive design that checks to see if your phone is near your computer, or that your phone has been dropped on the floor. All kinds of interesting ways of reacting to the hardware and outside of your actual physical device. And then with Web USB, that's going to open up all kinds of things because you'll be able to plug in your Arduino, you'll plug in any serial device and start talking to that just as we were doing with the Arduino. Just the other day, I saw this. This is completely unofficial. It's so early draft that it couldn't even be considered to be a spec. But it's quite exciting that people are potentially suggesting that why don't we implement Johnny-Five's API directly in the browser? So there would no need for intermediary steps, proxying things down to Node and then over to an Arduino. You just do it straight from the browser, meaning that there's even less to think about. You can literally use your web development skills with an API that talks about some hardware, and you're good to go. So basically, the future is very bright. Go forth and make robots. Hopefully this has inspired you a little bit. Thanks very much.
That was awesome.